Good morning, everybody, and welcome to this talk, which will be delivered by Maria Pregnolato. I am Emma Rose, Faculty Projects Manager for the Faculty's Industrial Liaison Office. If you have any questions today for our speaker, there'll be a Q&A at the end of the presentation. Please submit any questions you have to the Q&A found at the bottom of your Zoom screen. This talk is part of our Faculty Research Showcase event. The purpose of this week-long event is to demonstrate the breadth of research capability we have in engineering at Bristol, to provide stimulus for a conversation and hopefully future collaborations. I will now hand you over to Maria, who will talk about urban resilience, a climate impact perspective. Thank you.
Thank you. So, good morning, everyone. I'm actually very happy to open this Faculty Research Showcase this year, which is a particular year, as everyone knows, because it's not live, but it's a virtual event. Nevertheless, it is going to be a very nice showcase, and not only to show you everything that is going here at university, but also to try to open the door for a two-way dialogue in order to understand what are your needs, your agenda, and try to co-work and co-research on the big challenge of our society. So I'm a lecturer in civil engineering, in particular in infrastructure resilience, and my talk is about the impacts of climate and climate change on in cities, in particular looking at the flooding and urban transport networks.
Okay, Houston, we've had a problem here. This is Houston. Say again, please. Houston, we've had a problem.
I think everyone knows that actually we don't have just one problem regarding cities, we have many for sure, but one of the most compelling is actually climate and climate change. This because current projections are saying that we will have a hotter summer, and so connected to drought, and wetter winters connected to more flooding in intensity and in frequency. And cities are overall vulnerable systems because we have the highest concentration of population, we have inherent complexities due to technology, due to the high density of structure, and this situation is going to be felt more and more towards the years. However, if cities are the problem, let's say, due to the complexity and the fact that many people are living here, they can also be seen as the solution. This because cities are also the concentration of resources, of technology, of knowledge, and they are underpinned by a backbone of system that if they are made resilient, they can improve the overall resilience of the system. And these particular network systems are infrastructures. And infrastructure spans from water system to communication and energy passing through transport. And they are really the key, the backbone of the smooth functioning of our cities. This is why it's so important to try to focus on them and to try to improve their robustness and their redundancy and their resilience to overall external events such as climate impacts. So my talk today is not only to showing some results of collaborative projects of the recent years, but also then to dialogue with you, just to understand your needs and your capability and your interest in this type of research. This because, as I said, cities are very complex systems in which multiple disciplines and actors and roles are present. And so it's very much important that everyone is able to bring his own brick to the research landscape in order to work together for a common goal. The first case that I'm reporting is about road resilience, and is a case study that I developed with and for Newcastle City Council, focusing on the city of Newcastle. So for this case study, I studied the vulnerability of roads to flooding, considering a criticality of the major networks in cities. And this criticality is mapped on the map from red, which is a high risk to flooding, to green, which is a negligible risk to flooding, considering a quite high flooding scenarios, such as an event of a 1 year in 2,000 years event. And this type of consideration, considering the high risk of, or the the likelihood of the risk of the major networks is very important, especially when you plan for rescue and evacuation planning or for the accessibility to critical infrastructures such as hospitals. And the accessibility of critical infrastructure was also investigated in another collaborative piece of research with the University of Florence and the Civil Protection of Florence. This is a town very close to Florence named Galluzzo, for which we wanted to collaborate with the Civil Protection in order to provide input for their annual exercise for planning and preparedness of risk. So these three boxes represent three different time frame. Box A is the baseline, so the business as usual. B1 is when flooding has started and 20 minutes has passed. And T2 is after 40 minutes, the beginning of the flood. The colored area represents the area that can be accessed in the time permitted by the legislation from the town center of Galluzzo. So for the baseline, you can notice that all the hospitals and all the fire stations can be accessed during the time allowed by the legislation. However, if the rescue system waits for 20 minutes from the onset of the flooding, they have still a good accessibility to critical structures such as hospitals and fire stations. However, one hospital started to be cut out of this accessibility area. But if the civil protection waits for 40 minutes since the onset of the flooding events, it is possible to see how this accessibility area has completely shrunk and all the hospitals and all the fire and police stations are out of the reach of the city center. So again, this type of analysis are quite useful when you plan your time frame and the work tasks during emergency plans. The second case study is about bridge resilience, and bridges in my research are looked at both perspectives as structural elements, but also as key elements within the transport network. The case study here is in collaboration with the University of Washington and Highways England, and is looking at the city of Carlisle, which is a very flood-prone town in Cumbria. Carlisle is quite interesting because is across the River Eden, and many bridges are present with different characteristics and different owners. We started this piece of research by focusing on the M6 bridge, which is a bridge in concrete, quite a big bridge owned by and managed by Highways England. And so we started to look at the drawings and the characteristics and try to understand which kind of impact a high flood event, a low probability, high impact flood event could have on this type of structure. So in collaboration with the School of Geography at the University of Bristol, we started to understand and to draw various scenarios of flooding in order to calculate the flood depth and the flow velocity to be applied to the structure. The second stage was undertaken by the University of Washington, who developed a model using new techniques of computational fluid dynamics in order to understand the relationship between the loads and the pressure given by the water and the structure. This type of analysis then was followed by analysis in more structural programs such as OpenSeas in order to understand the response of the structure. The final step was to have a system perspective, having a wider look to the network and considering the role of the M6 bridge in the traffic flows. So essentially, again, the green line is the baseline, so the normal route that people would take to go from one side to the other of the River Eden. However, if the bridge is no longer usable, then there are rerouting for private vehicles and for EV vehicles with different time and length. And this, of course, has to be seen as base case scenarios because congestion and traffic lines are not considered, and so the impact of the absence of the failure of the bridge would be very much felt in the normal way of things. especially if we consider that the cost, in this case of incidents, should take both the direct costs, such as the repair and the cleaning of the bridge, but also the indirect costs, such as the cost due to detours and delay in business. And overall, these are a very big cost for the society and for the community. The third case study is about scour.
These pictures are from the Greek island of Crete. Heavy flooding caused this 111-year-old bridge to collapse. The island has seen days of torrential rain that killed a farmer. Roads, buildings, and infrastructure have been damaged and some homes evacuated.
So scour is the phenomenon of erosion around the bridge piers, and is cause number one for bridge failure all over the world. So this is why it's so important to investigate it. And nowadays, the normal technique of monitoring scour is actually visual and manual inspection, which are of course very costly procedures and also quite dangerous one, especially in the case of flooding. So nowadays, we are trying to shift the attention and the practice towards structural health monitoring, which means placing sensors and devices on bridges or using remote sensing devices in order to try to monitor the risk to the structure. And there is actually a very long list at the moment of devices that can be applied with various results, various costs, and various type of resolution. So for this, I'm working with two partners, James Fisher Testing Services and Network Rail, and we are trialing 3 test beds in Wales. The major point here that we would like to mention you is a rating of scour sensors that I developed with some colleagues here at the University of Bristol in order to understand which sensors would be best to suit your structure and your context. So we are considering 5 criteria which are related to the installation, the operation, the data collection, data interpretation, and the frequency of the measurements, in order to give scores that allow you to understand how good would be a sensor for you. And for each criteria, there is an accurate description for the score from 1 to 5, with also examples in order to help and assist with the rating. So in the case of installation, for example, visual inspection has the lowest score since it requires diving team, which could be dangerous and unpractical, whereas the higher score is when you have something that is fully remote, so you don't have any obstruction to your operation. For the ease of operation, again, we have 1 when you need, for example, visual inspection and a diving team, and instead we have 5 when you can operate without any specialism or training. And similar description are given for all the 5 criteria. I'm not going here into details, but I will be happy to talk more if you're interested, in order to help you to build the score for your device. This score, which is obtained by summing your scores for each criteria, will give you an idea of the applicability for scour and detection and monitoring for the device or the devices that you have selected, from very low applicability to very high applicability. Of course, the devices that are scoring very low should be disregarded, and only the ones with a very high applicability bring forward for further investigation and then trialing on the structure. The last case study is actually one of the most inspiring pieces of research that I've done, I think, in my life, and is about digital infrastructure. The case study also is very fascinating because it's the Clifton Suspension Bridge in Bristol, which is not only a very interesting and challenging case study, but is also a symbol for our city, which made things much more pleasant to be investigated. The idea here is to build a digital twin of a piece of infrastructure, such as a bridge, in order to improve maintenance and understanding of the structure. This project is part of a major program at the University of Bristol and throughout the UK, which is a UCRIC, which develop and collect data in order to improve our understanding and our capabilities in the built environment. This project has involved many colleagues at the University of Bristol, and the talk after me with the Professor Sextos will be actually about UCRIC and the facilities around this program. Here for the Clifton Suspension Bridge, we are putting together the capabilities that we have for virtual models, such as those developed in engineering software, and the capability that we have from sensing and monitoring of structure. So from one side, as I mentioned, we have the 3D model in which we have simulated through a finite element model the bridge to understand the various elements, the loads, and the behavior of the bridge, simulating it through normal techniques within the software. On the other side, we have the sensing. So previous case studies that were undertaken at the University of Bristol by Sam Gunner and other colleagues had seen the deployment of few sensors on the Clifton Suspension Bridge in order to understand stress and strain on the structure due to a series of factors such as traffic, wind, temperature, and so on and so forth. A dashboard was put in place in order to visualize such results and also try to merge the gap between research and decision making. The next step would be to put in relation this data collection with the 3D model in order to have the twinning between the two and having a sort of right time decision-making and monitoring of the structure. As I said, this type of tool, a digital twin, is seen as the future of infrastructure management because could allow a better understanding of the problem of the structure, of intervention due to maintenance, as well as testing of new intervention before actually deploying them. I would like to conclude just to give you my vision for the research agenda, what I have in mind to continue to do, and what I can see in the horizon for infrastructure resilience. So first of all, I think it's pivotal to continue to work on resilience to flooding for road network, given the key role of the transport sector during the emergency. Secondly, I would like to continue to work on bridge and transport resilience, looking at bridges as key elements of the transport network, but also as very fascinating structural elements. I will also to continue to work on monitoring and scour risk assessment, because I think that structural health monitoring is really the way forward in order to take control of the assets and avoid failures in the future. I would like also to continue to work on digital application for infrastructure, going towards digital twin and smart bridges for understanding how we can optimize maintenance and intervention for our infrastructure. And finally, I would like also to start to understand the capability of remote sensing for bridge health condition, in particular, for example, the use of LiDAR and INSAR for assessing bridge problems and bridge structural response. But actually, as I said, this presentation is not just about us or my work, but it's actually to try to explore areas in which we can work together. So I am really interested to know what actually are your needs, what you see in your research agenda, and what you can think that the university can do with you. Because I know that for an industry, for a company, the research and development could be tricky to be deployed and developed with a fully program, but actually this is why collaboration should take in place. So I would be interested to know about any case studies you have, you think could be placed for further research, or any feedback that you have on the case studies that we have already. I would also be interesting to know about new studies that you can propose in terms of feasibility or exploratory, as well as blue sky ideas, because actually the university is really the place to explore things that could be also seem a bit crazy or out of the box, because always good things can come by thinking widely and out of the normal routes. How actually can we work together? So for sure, you are aware about the route of research grants or innovation grants, that are the grants that can be led by external partners and not by research institution, as well as we can help with the business tender. I've also been involved in various policy and consultancy briefs, so also this could be a route of collaboration, as well as taking part, collaborating within master and PhD projects. This is something very viable for contained piece of research that needs immediate exploration. And finally, we are also open to hear ideas about prototyping and lab test and anything that can be done here in our infrastructure facilities. So I really thank you for the attention this morning, and I hope you found this stimulating and inspiring, and I'm open here for any questions and any comment you may have. Thank you.
Many thanks, Maria. A reminder, if you do have any questions, please type them in via the Q&A tab at the bottom of your Zoom screen. We have the first question that's come in from Sarah, who asks, could you expand a little more on why industry involvement is important in your research?
Yeah, of course. As you may have seen, like each case study is working with a few partners. This because for me is very important that what we do at university is not only something wonderful in the world of ideas, but actually is quite grounded on the society and on current problems. And just by having input from outside, from stakeholders, industry, company, and public agency, this is the only way to make sure that the research is useful and the outputs that we can produce can be used and are tangible. So I think that all of my projects always try to start from societal needs, a real problem, and a partner that has interest to work in that and establish the pipeline of the works together, so that the outputs that at the end we will obtain, they can implement it with the practice or guidelines or anything that is actually tangible.
Great, thank you. I can probably answer the next question. It's more of a housekeeping question, which is just to confirm that the recordings will be made available to everybody who attends. We will send out links to the recordings within the next couple of weeks when they are uploaded onto the website. So you will have access to those once they've been edited and put onto the website. Does anybody have any further questions that I can ask of Maria? We've got another question that's come in, Maria. Where do you want your research to be in 5 years' time? Where do you imagine it going in the next 5 years?
Yeah, no, this is of course a very good question, because I mean, we have to work short term, but then I've always a vision of long term. So as I said on my research agenda, I really believe about the digitalization of infrastructure and the use of sensing. So essentially the merging between technology and computing science and engineering. And I think the direction of digital twins and monitoring system is really promising, because we are, let's say, reducing uncertainty linked, for example, to subjective inspection or to expert opinions, and try to use the intelligence of computing system and of calculation for making decisions for us. This doesn't mean that the human will disappear, but the fact that the decision makers will have tools and which will produce much more informed information, and so hopefully to produce more more decisive, more reliable decision, as well as practice, as well as improved practice. And this is very much connected, especially in terms of optimization. So nowadays in maintenance, there is the problem about prioritizing resources when they are limited. And I really believe that this type of tool will help very much in this type of direction.
Great, thanks, Maria. Another question that's just come in. How are you joining up with other academics across the university to tackle climate change? So other academics in different disciplines across the university to specifically tackle climate change?
Yeah, so here at the university, we have a cross-faculty and cross-school institution, who is the Cabot Institute for the Environment, whose role is exactly to maintain active the dialogue among other academics about climate and all the environmental issues that are going on in the university. So actually, I'm in connection with multiple faculties and school here. As I mentioned, for the case study in Carlisle, I was collaborating with the School of Geography. But in general, the dialogue is very much cross-school and cross-faculty. There is no border about talking about climate change at the university. Another example is the COP26 that is happening in Scotland this year. And also for this event, there is very much collaboration within all the colleagues at the university. Just because, as I said, contemporary problems are no longer silo discipline problems, but they cut across all the spheres that are involved in the society, from engineering to economy, to society, to politics. So there is really no point to contain one topic just on one discipline. I think we would miss a very big part of the perspective.
Great, thank you. If there's no further questions coming on the Q&A at the moment, I might bring the session to a close, unless anything comes in the last 30 seconds. No, it doesn't look like it. So thank you very much, everybody, for attending and for your questions. I'd also like to thank our speaker today, Maria Pregnolato. In the current climate, as you know, online is the only way we can do this type of event. And we appreciate it's not as interactive as we'd like and as interactive as we used to. However, if what you've heard today or throughout the week has captured your interest, please do get in touch with us. Our Industrial Liaison Office is here to connect you to our academics and students, and contact details will be sent after this event. Many thanks again for attending, and goodbye.
Thank you.